Thank you for coming to this first session, Design and Commissioning. It's a credit course, so feel free to move up front. We won't have a bare front row. Appreciate you being here. Welcome. How many new people here for the conference? Terrific. We welcome your feedback. We welcome your questions. We've got some real experts here, so make yourself part of the family. My name's John Rath. I'm Director of Operations for NY-GEO. I'm the proctor today, which basically means that if you signed up for credits, I make sure that you sign up on this sheet. Should be pre-populated with your name. If it's not, I've got some blanks, and we'll take care of that when you sign. It'll be afterwards, so that we make sure that everybody who is here is actually on the signature page. Give it a minute for people to wander in. We're going to have the presentation for about 45 minutes, and then we're going to have about a 15-minute Q&A session. Lots of slides, so take notes. If you can, please hold your questions until. Do you want to wait until after to deal with questions?
I can entertain them.
Okay.
If needed.
You be the judge. If it's a timely question, then ask it, right during the presentation. The question is about signing now or at the end of the presentation. At the end. Our notes in your publicity was a little bit off. We don't need you to sign in. We just need you to sign out. Today, I have the pleasure of introducing a guy that if the word energy is anywhere around him, he's experienced it, invented it, done it, consulted about it, or whatever. Khaled Yousef has like 30 years experience in the energy industry. From coast to coast, he's worked with NYSERDA in New York State. He's worked with the California Energy Commission out in California. He is the founder, owner, leader of his company that's called Pyramid Energy Engineers. And so take advantage of his expertise while you're here. I want to have you give a warm welcome to Khaled Yousef.
Thank you, John, for your kind words. Now I can turn on my microphone. Everybody hears me okay here? Perfect. Welcome to NY-GEO here. I have been part of this conference starting in 2015 on and off in Albany and here in New York City now. I look forward to share with you a very interesting subject about the proper commissioning process here. And we're going to be going through a lot of slides today, so bear with me here. And this commissioning applies to geothermal heat pump systems here, as well as numerous other building types here. So the technology is the technology. We can apply it to many, many buildings. And the other thing about commissioning, it applies to geothermal systems as well as numerous other technologies with cooling and heating and controls. And some disclaimers here to keep the attorneys happy here. And you can read it because you're going to get a copy of the slides after that. And I'm very objective and independent here. I don't sell any equipment. I just provide you with what I believe is the proper advice that works for the site here. Some disclaimers here about what goes on the slides because I could have some illustrations there. So just to be aware that you are not going to get a successful commissioning process or a project unless you follow the commissioning requirements from A to Z here. Attending a course does not make anybody a commissioning expert here. You got to go through the process of doing the commissioning the right way, and there's going to be multiple steps for doing that. Regarding the audience here, even though this is a PDH approved course, this is not just for professional engineers. Basically, everybody is welcome here. Engineers, technicians, contractors, professors, students, because the commissioning process is a quality control process that we need in a large number of projects, not just geothermal heat pump jobs here, but anything to do with the building industry, as well as some R&D and demonstration projects. It's a quality control process. And basically, simply I like to say, it doesn't matter whether you commission a $500 hydraulic chair or a $500 million nuclear submarine. The steps is what we want to talk about today. This session presents an overview of the proper commissioning process and points 6 types of commissioning, depending on what's required or specified. And it outlines as well 4 phases of the commissioning process, because a lot of people think commissioning, hey, let's just come at the end and do some testing. There is a lot of preparation work to be done prior to that. So we're going to be covering a lot of subjects today, and at least you don't have to memorize anything here, just understand and comprehend there is a process that needs to be followed. This course caters by presenting a proper commissioning process, 6 types here. The total commissioning process, and teams' roles and responsibilities. I want to make sure I focus on this, because when these slides were made, I started by troubleshooting buildings that had numerous problems. And what we found is that in many cases, these team roles and responsibilities were not defined up front quite well. So there's going to be a lot of upfront planning here. And there is going to be commissioning reporting. Again, it's a nice and structured process here. Keep in mind, I'm trying to put 8 hours worth of material here in an hour session here. So bear with me here if I go too fast, but you're going to get a copy of the slides after that here. And we want to make sure that this is a well-integrated and holistic project development approach here. And it's not that we're going to work in silos. We need to work together as a team and enhance our communication in the commissioning process up front. Successful HVAC and MEP building process automation systems, like you call it EMS, BMS, or SCADA installations, covering a wide variety of conventional, progressive, and renewable heating and cooling systems and technologies in varying building types, sizes, covering residential, commercial, institutional, and industrial facilities. Again, you could have $1 million building, $1 billion building. They all require some level of commissioning here. IDP, if you remember back in the 90s or early 2000s, ASHRAE started to have these satellite broadcasts. It was an actual satellite receiver, and there was a lot of talk when this integrated design process started. And we realized that a lot of members of the team were not communicating with each other, which is why we had failed projects or projects that we learned from. This is the some of the objectives here and the sources of the information I've been working with over the years. The United States Department of Energy doesn't get a lot of credit, enough credit for what they have done back in the late 80s, early 90s, when they commissioned the Portland Energy Conservation Initiative to start the commissioning process. So there is a lot of good history here regarding how commissioning was started. ASHRAE, the American Society of Heating, Refrigerating, and Air Conditioning Engineers, they have a lot of manuals about that. Again, started around the 90s, and then we had multiple versions after that. I looked at numerous other sources, and basically the most important thing is that I've been on the field observing systems in operation, observing systems that have challenges. So that's why there is multiple sources here for putting together these slides here. I'd like to make a differentiation between the existing and new building commissioning. I think John Chifago asked me to speak about retro commissioning. I can't talk about retro commissioning without really taking you the steps of what we need there. You are all dealing with existing buildings as well as new buildings here. It's easier to commission a new building because we can plug in the appropriate building management sensors that are needed for balancing and commissioning and controlling a building. But if you have an existing building, you don't have all the tools necessary at your disposal for doing the commissioning process and proper controls, which is why you would need to add a lot of data points and sensors to be able to observe and see what's going on in these buildings here. So this is something just, there is also the monitoring-based commissioning, which uses a lot of data sensors. Like there is, you're going to have a floor plan of the building, a mechanical plan. It's going to have a lot of sensors in specific locations that are needed for controls and for commissioning here. Learning objectives here. You're going to know some barriers here of why sometimes you cannot commission. It's too expensive, or the owner doesn't have enough knowledge about the value of commissioning. We're going to talk cost about how much does it cost to commission, what the cost is not commissioning, and all that stuff here. And there's a lot of lessons learned categories here. Basically, I want to be thankful for all the customers, all the contractors who let us in their own buildings to basically learn from them what happened and what went wrong through a troubleshooting process. So there's been a lot of collaboration. Nothing is called a failed project. It's a project that we learned from. And those were very valuable here because there is a lot of lessons learned. And it's funny, they apply to the geothermal heating industry, heating and cooling, like many of you here, as well as numerous other mechanical systems. And for more details here, I have an eight-hour course that's detailed. It's online. If anybody needs more detail about the commissioning, this is available here. Important of the commissioning, there are definitions, sources, and resources here. There is a definition here that was just going to be very general that we've used over the years, but there are going to be ones that are more advanced. Sometimes we used to call it like a testing process or an examination process, but it's more of a proper planning process here. In general, commissioning here is a systematic process of inspecting and testing building systems to ensure they are installed properly and operate in accordance with design intent. That sounds really good, but is that enough? The answer is no, that's not enough here. These definitions, what you're going to see later on, need to cover all phases. If you notice what happens here, we're talking about commissioning after things were built. But over here, we want to start prior to that. So here, this is a very important slide. Had to put this one in here. And if anything you get today, this is one of the important ones here, because ASHRAE talks about a quality-focused process, all right, for enhancing the delivery of a project, okay? It's any project, any mechanical, electrical, or plumbing system. The process focusing upon verifying and documenting that the facility and all of its systems and assemblies are planned, all right? We start with planning here. Designed, installed, tested, operated, and maintained to meet the OPR, the owner project requirements. So this is one of the most important things here, is that don't just go on commission at the end of a project after things went wrong. You got to start early enough during the planning process here. And this one here as well is that the process begins at project inception during the pre-design phase and continues for the life of the facility through the occupancy and operation phase. During the pre-design phase, the OPR, owner project requirements, are determined and documented by the commissioning team, all right, which includes the owner. We want the owner to be involved, the commissioning authority, the design professionals, the operation and maintenance personnel. Don't underestimate them because they are in the building all the time. And the occupants of the building, the users, through each phase of the project, deliverables, drawings, specifications, submittals, construction, and training are verified against the OPR. The OPR becomes a document. Even put it on an 11 by 17 sheet on the wall, and that's what we need to guide our entire project development for. You want a system that's efficient, reliable, easy to use, maintainable, saves you that much money. Listed up front there, right? And here, basically, when we say total building commissioning process, we've used many terms: holistic, thorough, complete, extensive, or multi-phase. So basically, that's the 4-phase commissioning process, spans from pre-design all the way into occupancy and operations. This is the Cadillac, basically. Get it done appropriately and correctly all the way from the project beginning to the end, and be thorough and do not cut corners. So the message here, start early with commissioning. Some customer called me one time, says, hey, Khaled, I want to pay you some money here. Why don't you come and check out this building here? With absolutely zero planning. I did not even have a blueprint. I did not even have a sequence of operation. There was basically nothing. So basically, it's, that's not the way you do it. And here are the four phases here. Basically, pre-design. Basically, when the owner and a candidate consulting firm are getting together, we need to think about that. And during design itself, the 30% CDs, 60%, 90%, 100%. CDs are construction documents. They are going to be checked against the commissioning process because there is design reviews. When you do design reviews as the commissioning agent, then you are being able to tell everybody in the team, this is what we will be testing in the future. So you incorporate commissioning here. Commissioning during construction, sites, eyes on the equipment that's being built, which is why the commissioning agent will probably have to be local. It cannot be somebody who lives many hours away. During occupancy and operations here. So again, this is the quality-focused process of enhancing the delivery of a project. The process focuses upon verifying and documenting that the facility and overhead systems and assemblies are, again, from planning to all the way through construction. And we talked briefly about existing buildings, new buildings, and some of the existing buildings, substantial renovation, are classified as new buildings because once you renovate a substantial amount, your code requires you to be treated as if it's a new building unless you ask for exceptions here. And talking about here the total building commissioning process here. That's another slide here. Again, more definitions for more resources here. This is an updated definition from ASHRAE here, talking about, defines the process as the ensuring that systems are designed, installed, functionally tested, and capable of operating and maintained to perform in conformity with the design intent. Okay, we're going to keep the design intent, owner project requirements throughout all the stages. In this guideline, commissioning begins with planning and includes design, construction, startup, acceptance, and training, and can be applied through the life of the building. So commissioning doesn't stop. Once the building is built, started, there has to be an ongoing commissioning manual of what data needs to be collected, how often, and basically how it's viewed, and what action items to take if a system deviates. And the California, some guidelines here give other beautiful write-ups about this. Why commissioning here? Ensured correct geothermal system operation, controls, and integration with existing HVAC systems, energy management control systems, and heat distribution systems. Again, integration is a key point. You are not just installing a well field or a heat pump. You want to make sure that well field heat pump works with the existing mechanical systems that could be hydronic, that could be air, it could be a mixture of air and hydronic, radiant slabs, just make sure it's all integrated together here because we have been siloed. Everybody has a small scope of work. Contractor wants to go get the job done, get paid, and move on. No, we need to talk together and make sure it's all holistic and integrated. Verify properly sized system components, which is basically heat pumps, actual pumps, pipes, the ground heat exchanger. You don't want to oversize too much, and that's a problem we have. We say we have poor project economics, and the project has been oversized, breaks the bank, but guess what? You can have a smaller project, but maybe inject some propane sometimes during if it's 20 below. So this way you can save a ton of money on the ground heat exchanger if you're willing to cover like 3% of the time when it's 10 or 20 below in New York State by doing that. So you can do a lot of upfront savings this way. Verify the effectiveness and benefits from the ground heat exchanger thermal storage year round. You want to make sure that this temperature is swinging up and down, all right? And it's the same thing for 10 years. Because if it deviates and it's too cold or too hot over a 5 or 10 year span, means that ground heat exchanger is going to be ineffective after a while. And then you have to have a cooling tower or a boiler, and that does not become a good story. Commissioning will help you identify these issues up front. Support future quantification of energy and cost savings and performance validation and measure. COPs at various loads. Yesterday we were at the tour, and some sites might know the COP, some sites don't know what the COP is, coefficient of performance. So by having a proper building management system and data points, you can automatically calculate this. Sometimes the chilled water plants, we call it the wire to water. How much electricity comes from the wire, how much BTUs we send out. You can call it whatever you want, but without having the proper tools, you're not gonna be able to see this number. Other technology-specific examples here, facilitate accurate and fair billing in campus settings. Right now, New York State is going to be talking about a lot of thermal energy networks, and there is going to be a lot of billing. We want to make sure that billing is right. Through that billing, we can identify problems as well. If a space is consuming too much or too little, maybe there's a problem with the meter. Maybe there's a window that's open all the time. You know, something is wrong here. So that will help us out with that billing here. Ultimate targets to ensure we deliver conditions where ground is warmer in the winter and cooler in the summer. We really want to watch for this because we have the beautiful earth in our lawn as a massive thermal storage medium here. So that's what we want to make sure from the building management system. Overall, use your imagination from your experience, and if you review the detailed lessons learned slides, again, this is more detailed. You're going to see that commissioning had saved buildings in probably at least 120 or 150 problems that I have identified myself. Had we gone through commissioning, those would have been avoided, and millions of dollars wasted by not commissioning these buildings properly. You're all familiar with some of these beautiful consumers, prosumers here. And again, if you have a commission system where everybody is working together, we're going to see who is contributing to the loop, who is extracting from the loop, and do the COP calculations. And if something is like a COP of 9, something is wrong. If there is a meter problem. Some COP of 2, something is wrong as well. The system could be inefficient or a metering problem. So by watching these numbers carefully and doing regressions against outdoor air temperature, ground temperature, building load, even cloud cover sometimes, we are going to be able to see if there's any deviations in the system here. So use that building management system and ongoing commissioning to basically be able to identify issues in the systems here. Why commissioning here? A quality focus process here, a lot of other definitions. OPR and BOD, how many of you are LEED certified here? Okay, so you're familiar with OPR and BOD here. Owner project requirements, basis of design. They are not followed properly in many projects, but want to make sure part of a good design team is to have these in place here. Why commissioning again? Comprehensive quality assurance program, beginning with the pre-design through the design, and basically you want to make sure the finished facility operates as intended. Unfortunately, after all contractors leave the site, the owner is there holding the bag. You know, everybody left, everybody got paid, but the owner will have to live with this building for 10 years, 20 years, 50 years. So we want to make sure the owner has what it needs to make sure that the facility operates as intended. This is the CX Handbook, second edition. I would have liked to bring a box of commissioning resources, but I didn't want to carry too much here. For the hour, we're not able to cover that, but there's a lot of good references out there. How much does commissioning cost and how much can commissioning save here? I tried to answer that question. There isn't a straightforward one, but commissioning will generally and will definitely add cost to the project. First cost, no doubt about it, including commissioning and test and balance, but it will save a lot of energy and money over the building life cycle cost. Basically, it could be 30 years, 50 years, or 100 years for a ground heat exchanger. So there is a lot of savings here. And the bottom line is that the cost of building commissioning is less than the cost of not commissioning a new facility or an existing facility. So basically, you save by commissioning. Commissioning is almost a free thing if you look at how much you're going to save over the years. The building commissioning is important for the success of capital construction projects and should be budgeted for during all project phases. And commissioning has an attractive rate of return on investment. That's even better than a CD. Look at how much money you can save. Simply, you cannot afford not to commission. Funny, I got a call one time. A job has been built, almost 90% done. The commissioning section was removed from the spec book. It was removed because they wanted to save money and said, can you commission this? It's a can of worms. The GC is notorious for change orders. Lawsuits were starting already. You can't get through a can of worms like this. So how can somebody build a $108 million project with complex systems with the commissioning removed out of the table of contents and out of the spec book to be able to make it doable? They paid for this project much more than what they would have paid for commissioning properly upfront. And it happens, unfortunately, in many public and government projects. I've seen disasters to the point sometimes it says, I cannot get involved. I'm sorry, this is too much. I don't want to end up in court. So you cannot afford not to commission. That's the bottom line here. Commissioning has numerous benefits, one of which is it helps fill gaps in the needed coordination that agency generally lacks in projects such as communication, and coordination is key. Again, the commissioning agent has a very important role because you got mechanical engineers, electrical, plumbing, you got a general contractor, you got a construction manager, you got the owner. There is not enough communication here. And also you got the equipment vendors. If somebody is there looking at everybody and communicating, and sometimes those two guys need to sit together here and figure this out and update the project team. Do it up front, don't wait till the end. This supports IDP, which is the integrated design process. Some studies here in 2004, sorry this is old, but I loved it here. Lawrence Berkeley National Labs in California said estimate $18 billion year of potential savings from commissioning through the United States simply by looking at these 13 folds here. So they did a lot of buildings. They had a big budget. They went out there and commissioned this. That was, I was in California before this study was made, but I know they were going to be working on it, and there were teams of companies. Look at duct leaching. HVAC operates continuously during unoccupied periods. How silly is that? All right, lighting system illuminating space during unoccupied periods. HVAC systems improperly balanced. That lack of balancing is an absolute disaster here. Improper refrigerant charge. How many of you have seen what happens when a charge is not right? Economizer dampers operating incorrectly. It could be stuck open or stuck closed. Stuck closed, you get sick building syndrome. Stuck open, your energy bill is up the roof, and your cooling coil, the heating coils freeze. And you get a rain after that in the building. Insufficient evaporator flow, improper control setup and commissioning. This is very critical here because this is the one with the controls. This is where all the worms are. A control system looks at everybody, basically makes sure everything works together. A control component failure or degradation, software programming errors. Programming errors are serious as well. Improper controls, hardware installation, air-cooled condenser fouling, valve leakage. The one I want to add to this, I would have loved to see in the study, but it wasn't there. Heating and cooling systems fighting each other. This is by far the worst. You put your infrared thermometer here, it measures 100 degrees out of the duct. Over there, it's measuring 60. They are fighting each other. And it could happen for many years, unknown. So that's my 14th edition here, if I can go back to Berkeley and add this. USDOE, Pacific Northwest Labs here, they are giving you some paybacks here. I won't go through all of them for the time, but you can look at paybacks of less than 5 years. I mean, a lot of them are low cost here, so there's a lot of savings from commissioning here. And here it also found that when commissioning is incorporated through the commissioning process, throughout, twice the overall mean level of savings, 5 times the savings of at least over the least thorough projects here. So you can look at the value of starting up front, all right? And those are some ranges here. Many of us like dollars per square foot. Again, the study is old. Buildings cost about $1 to $3 per square foot per year, unless you have a data center or something, you go $50 or $100 per square foot per year. But what people are not aware here, if the building is uncomfortable, you are losing more in employee productivity. Look at the salary per square foot of employees there. And if we have a building that's unproductive, then our loss in productivity for the business is worse than the loss of energy. Not supposed to say that in an energy conference, but that's actually reality here. So those are some numbers here and some ranges there. And I've looked up some of them myself when we did some commissioning work many years ago. How much is the cost of commissioning and how much can we save? Can we get a payback of 1.5 years or 2 years? And it's very promising, actually. How much can commissioning save? More details here about this here. New construction commissioning, and sometimes, you know, unfortunately in new construction, there is more complex systems and actually worse conditions than a simple building. For example, a customer upgraded their warehouse maintenance facilities with all kinds of beautiful systems there. The baseline cost was about $1.50 per square foot. The finished building was $3 a square foot. How did that happen? They did not do energy recovery. It was too expensive. So they had 100% outdoor air systems to be able to feed the bus garages for maintenance without recovery. So, I mean, that's why the cost was double. So we had to go back to design engineer. Why did that happen? Well, it was the owner. They blamed it on the owner, the poor owner. So, and the owner approved the change order to reduce that, to save some money and build the building, but obviously paid it in energy after that. Commissioning process, key components here. Commissioning plan, you need to plan for something to happen here. So there is going to be a plan document that everybody agrees upon. I don't want the plan to be done in silo by the commissioning authority. It has to be shared with everyone, and everyone has to put their input in it. Sometimes they don't like it, but we gotta negotiate that and discuss it here. Here are a lot of other definitions. Who is the commissioning authority? The person leading the commissioning process. And you know, more definitions from ASHRAE here about more references. I gave you my old references because I cannot afford to keep changing them every 3 years. ASHRAE keeps changing them every 3 years, but honestly, I looked at them over the years. The message is loud and clear. You cannot afford not to commission here. A commission process, basically the report here. The report follows the plan. Whatever you plan for, you want to reflect that in the report. And that report becomes part of the documents that are submitted to the owner after the project is completed here. A document that records the activities and the results of the commissioning process, usually developed from the commissioning plan with its attached appendices here. And it could have graphs and pictures and regression plots and all that stuff, because when you say, I basically commissioned the system, well, what's the evidence of that? You're gonna have not only photographs, but you have data and basically regression plots that shows that the VFD is ramping properly. In many cases, a VFD is used as a 2-speed fan. No, well, it should be able to ramp up and down as intended here. Testing, adjusting, and balances is tab. I like the tab contractor to be involved up during the design process. What happens is that when the building is built, they give a call to the tab contractor. No, that's not the way it's supposed to be. The tab contractor needs to be up front to make sure the ports that he or she would need for temperatures and pressures are available and accessible to be able to perform their duties. But sometimes I have to hear excuses. Oh, I couldn't get this. Well, why couldn't you get this? Because the port I needed was not here. So I've been saying to customers, please involve the tab contractor up front, testing, adjusting, and balancing. And it applies to both air moving systems and hydronic types. And as you know, with geothermal heat pump systems, you have hydronic, you have air, or you have air and water systems here. And this is ASHRAE established in 1894. Hard to believe that, before all of us here were born, but it shared a lot of good with humanity in general. We have chapters all over the world, and basically they write the standards for the refrigeration, for equipment, and a lot of good work there. A lot of volunteer work. Like this organization here does a ton of volunteer work. ASHRAE does the same thing too. What happens when a well-integrated and holistic project development approaches were not followed and was not commissioning? Just list 3 examples. You can think yourself here about what happens when something isn't commissioning here. Just for the sake of time, I'm going to go through them here. Lack of design review by an independent third party. lack of energy audit, lack of design team training here. So do an energy audit before you put a geothermal system in a building. Understand the building very well. Maybe it needs more insulation first, okay? Understand it quite well here. Do a utility bill analysis. Inadequate design drawings and specs. Sometimes we install systems without enough detail there. Oversized systems, inadequate building insulation here. You know, oversized systems, they break the bank there. You can't afford that. Unclear roles and responsibilities among project team members. We have a lot of people working a job. We got to define these up front. Lack of testing, adjusting, and balancing. Lack of commissioning process, issues logs, and project coordination meetings here. There has to be a log that says this thing happened on this date and time, that's how it was solved, and that's proving the result that it was addressed. Issues with early generation equipment reliability and robustness. That happens almost everywhere. I've seen this back in the CHP days, combined heat and power. I've seen it in biomass days with solid fuels, with ground source heat pumps. Any early generation would have its problems. So that happens as well. Lack of complete control sequence of operation. This is the devil here. You really need to nail this in bullet items, not long run-on paragraphs that are all uppercase. It has to be bullet items, clearly defined and reviewed by multiple project team members, because whatever you put in this sequence will not be programmed correctly from day one. I can assure you that. It's not gonna happen. You have to go through an iterative process, test it, make sure your sequence is actually working as intended. So those are just examples here. If you have commissioning, you can avoid a lot of these problems at the beginning here. Issue summary here. I looked at many projects here and I have like 21 categories. So basically, I don't want to go through all of them right now, but the ones I gave you here in the first slide were good enough just to basically summarize it here. And just so you know here, sometimes there is issues with government procurement processes, whether it's a utility giving a permit sometimes to do the work, or environmental permit. I've seen all kinds of issues that could happen if somebody slows the movement of a project here. It happens all the time. Besides the most thorough, but by the way, we're lucky here in New York State because the state is really behind geothermal here. So the state is behind what you do here, and that's great. But try to do this in another state that's not friendly, they can drive you nuts here. One time we tried to pass a pipe just around the road here. No, they can't. You can't do this. Why? Because you are going to be treated as a utility. And now when you're treated as a utility, there's a whole other set of permits you need to get to do that. So, you know, we're lucky here in New York State. Besides the most thorough and complete 4 phases of commissioning process, other types are here. We discussed those pre-design, design, construction, and occupancy. There is now other ones here like continuous commissioning or ongoing commissioning. From the name, it's continuous or ongoing. You need it for the life of the building. There are definitions, different types, but at least be aware of it. Commissioning does not start when a project is built. There is retro-commissioning and recommissioning and retro-commissioning. Again, to be able to arrive to what NY-GEO wanted to talk about, retro-commissioning here, I wanted to talk about a lot of basics on commissioning here. And now once you understand all these basics, we can come back and retro-commission a building that's in operation, because we're gonna have the history of the building, how was it designed, built, do you have any logs, and then look at the BMS data, and then be able to retro-commissioning. And retro-commissioning works beautiful when we have data from the sites here. I mean, looking at like multiple screens, for example, sometimes I put 12 screens right next to each other and be able to look at the BMS system of an existing building, and that's how we can retro-commission it, even remotely. Being able to look at the data, does it make sense, make arrows, colors, and all that stuff, and be able to ask the owner, the design engineer, the contractor, the controls contractor, how can we get around these? What's the problem here? So we can do retro-commissioning for geothermal heat pump systems, but you have to understand it. Commissioning light is something that's lower level of requirement here. Different types of continuous here. This is a continuous commissioning, and this is the ongoing commissioning. They have some differences. You can read the slides. And here the recommissioning here and retrocommissioning. Recommissioning means something was commissioned before, but it needs to be recommissioned. It's that simple. But retrocommissioning means something that has not been commissioned before, and now it needs to be commissioned. So look at the definitions carefully from ASHRAE here, because a lot of buildings need recommissioning or retrocommissioning. If you have a building that's going to have a change of function, it needs to be recommissioned. If you have a building that has not been commissioned, it needs to be retrocommissioned. Commissioning types here. OPR and BOD here, those are the major definitions here that I want you to know about. Just put this document up front. I hate to call it the Bible because we want to stay here all neutral here, but this is the one that everybody should be looking at, and sometimes you even need to sign it. So this is your goal. Commissioning other types here. LEED, they have basic requirements for commissioning here. You need to have the commissioning authority, OPR, BOD, commissioning plan, commissioning requirements included in the construction documents. You cannot bind anybody legally in New York State unless you have it in the construction documents. Implement the commissioning plan, verify installation and performance, and complete a commissioning report. So this is part of the prerequisite for those who are familiar with LEED, prerequisite 1. And then after that, they added what is optional, additional items here. Safety, basically they wanted you to go back, for example, do the back checks. So it's not just one process, you need to go back and revisit the building here. Review the contractor submittals during the construction. So this is a higher level of commissioning here. Develop a system manual for the operating staff. Verify completion of operating personnel training. One time I had to go to Buffalo and sit down with the training team for 8 hours and make sure how every control technician was trained. And at the end of the day said, can you do some programming functions? Can you change this? And once the technicians told me, yeah, the owner, representative said it's okay, then I approved the training here. So to perform a 10-month operations review. So that's why you can see here, with this enhanced system here, they want you to come back, do more reviews compared to the basic. You can basically define whatever you want out of commissioning. Commissioning team members. This is a very important slide. Again, I want you to come up with this today. Who is the team members? Project manager, construction manager, the architect, general contractor, mechanical contractor or MPP, test and balance contractor, commissioning authority, controls contractor, very important, electrical contractor, MMV consultant, the heat pump manufacturer. They have a lot to say about the equipment startup, but they're not the only player. I mean, you gotta involve everybody there. The ground heat exchanger contractor, the grouting work, other equipment manufacturers, suppliers, heat exchangers, valves, underground pipe, local authorities having jurisdiction. You want to make sure those are on your side. ESCO for financing, funding agencies, utility, very important as well, and specialty consultants. As you can see here, you're not going to design a project in silo. You got to involve everybody here to make sure that they are informed of what's going on with commissioning here. And they are adding input as well. Commissioning scoping meeting here, that's what happens in a scoping meeting here. Basically, you want to set up a meeting, okay, and be able to, a meeting agenda, distribute it, take notes, and make sure everybody sees these notes here. Suggested issues and resolution law. I'm not going to go through that chart in detail here, but that's something I came up with over the years to basically log everything that happens here. So basically in these areas, which you can't see very well, it's going to cover basically the equipment type, issue discrepancy. Basically it's a coding system for what is happening, what project phase, how it was found, how it was addressed, and evidence was addressed here. So, and this is a disclaimer here for the issues logs. Commissioning is schedule typical. And basically, this is, you got to do the pre-functional test before the functional performance testing. This is, it's a sequential process, as I've discussed today. And PDH questions here. Commissioning here is just a quick site visit from 2 to 4 p.m. with no need for any preparation and no forms, formalities. Let's get it done and move on. Is that true or false? Okay, yeah. If anybody says true, then get out of the room here. All right. Sorry, it's stupid, but I've seen it happen. All right. That happened to me. Per the ASHRAE guideline, what are the primary phases of the total commissioning process? We've all known about them here. Basically, pre-design, design, construction, and occupancy operations. It's definitely not a quick site visit like what happened in the first question. What is one of the best definitions of the commissioning process and why? I've showed you many, many definitions here, but I love this ASHRAE that put it together in one paragraph. I mean, that's wonderful. How many members are in the commissioning team? You can all look at your project and see who's going to be there. And it says here it varies. Make sure involve everybody. If you have a project involving a conveyor belt, get the people standing on the belt, voice their opinions in the project. Because if you're going to say something, the design engineer sitting in Boston is not going to know about it. So make sure that the local people speak up about it. Can PFC, pre-functional test, done before functional, functional and pre-functional. Pre-functional means before, functional means after. Basically, one has to be done before the other here. Pre-functional first, get it ready for testing, and functional performance testing here. What are the most important 3 items gathered in this presentation here? Basically, ask yourself, how am I going to do my job differently today because of what I've just learned in an hour here? What's going to change here? So must have a complete CX team, roles and responsibilities defined upfront, complete PFCs and FPTs, maintain and stay on top of the issues and resolution logs, take commission seriously for the future. I'm just trying to summarize the whole course here in this slide of what you need to do differently with this training here. What are a few of the most important ASHRAE guidelines? I've listed a bunch of them here for references here. You can spend hours and days and months reading about them. They are really good, but we're trying to give you a summary here, and that's ASHRAE here. Multiple credits here. I want to make sure that NY-GEO and DEC have helped me reach access to some of their sites. That was very important because I was able to troubleshoot systems and basically add to this training because of the actual credits here. This is NY-GEO here, this is the Department of DEC here, and that's my contact information if anybody has any questions. I am sorry we're rushing through a lot of things because I need to allow questions. I'm getting the message from him right now. So you did the marathon today. It's 8 hours in 1 hour. And in the afternoon, we're gonna talk about certifications here. This is some detail here with heat spring. That's the recorded 8-hour detailed commissioning course where I'm not going to be going at such high phase, and it's going to show you pictures from projects and all that stuff here. So thanks to NY-GEO and to the DEC for really, and many of the sites, for opening their buildings for us to learn from. Nothing is a failed project. Everybody has been a contributor. In biomass, in CHP, in geothermal, I hear a lot from our friends in the geothermal industry about things where they learn from. Lessons learned. How can we do it better next? And this is very valuable for all industries. Thank you all here, and let me know if you have any questions here. We got.
I thought you did pretty good there.
Oh my God!
Do a lot of stuff. Yes, thank you very much.
Can't believe it here.
So we've got about 10 minutes for questions, and when you do ask a question, I'm going to run over to you as fast as I can with the mic. Please state your name and your organization. Who's first?
Hi, Tracy Ogden, Brightcore Energy. Mine's more of a comment and less of a question. I am on the drilling side. We have a complete engineering team, and I know this was primarily focused on the HVAC. But I think what's often overlooked is that there is a commissioning process for the earth-coupled system. And it starts early and it starts often. Usually the geothermal is being installed in the ground before the HVAC is even, it's being ordered. Everything we do on the earth side is for the HVAC system. We are constantly commissioning and testing and doing the integrity testing throughout the process. That is our commissioning process, and it's often overlooked and not understood. And when we have to interface these systems, there's often no one there to say go, no go. Who's going to decide who opens these systems? And that's what you got to think about from the very beginning of this process. Me as a driller, being in this for 30 years, I know to look at the HVAC system and start looking at what the qualifications are and what the testing parameters need to be and what the water quality needs to be in these systems, especially if they interface. People don't think of that often enough, and the people in this room, I think, are generally on the HVAC side. I just encourage you to continue to think about the earth-coupled side of the system, the fluid, the integrity testing, and everything it takes to bring that fluid to your system, because ultimately, we're feeding these systems. And I think that commissioning piece is never understood. And I just wanted to make that comment from someone who installs the earth-coupled side of the system.
Thanks, Tracy. I think when John Chivacco hears this, you're going to be on a session next conference.
Thank you for your comment here, and actually everything you said would be part of the project spec, project manual, because the job of a proper commissioning agent is to listen to everybody in the project, involve you up front, make sure your experience is reflected as part of the commissioning and communicated to other parties. So thank you for your comment.
Next question.
Hi, Dan Mascola with the New York Power Authority. With regards to pre-functional testing and functional testing, is there an optimal time of the year to start up the system for the testing? Summer months, winter months, shoulder seasons?
That's a really good question here. It depends on the system that you're using here. When construction is completed, it's ideal to get the site ready for pre-functional testing, because that's a static process. But for the functional performance testing, you're really needing weather to work with you. You cannot commission a boiler in the summer or a chiller in the winter. So geothermal heat pumps are even more tricky because they are not interacting with air, they are looking at the ground. So you want to make sure that the ground temperatures do it over perhaps a whole year. That functional testing, the most ideal thing is that yes, you can do a test at the field with the forms completed, date, time, technician, but think about it. You want to be in the dead of winter or the peak of summer, okay, and then cover an intermediate season. Because geothermal heat pumps are a nightmare in the sense that that ground temperature, year one, is whatever is there, all right? So you want to make sure you do it as a continuous process for a year to really nail it. I'm sorry I'm not giving you an easy answer or easy out there, because we have something called deferred testing. And this system is for heating and cooling and intermediate seasons. It has a dedicated outdoor air system with it, a DOAS, all right? If you have chill beams or low temperature heat emitters. So the commissioning agent will really have to sit down with the project team and the design engineer and be able to schedule multiple commissioning activities to be able to sign off and says the project is running well. And then after that, you gotta let the BMS system track your well fields to make sure you're not swaying up or down. Measure the BTUs, how much is being extracted from the earth and how much is being put back. And that does not happen in a couple of days. It needs a year to be able to look at it. Unfortunately, my answer is long, but that's the reality of it.
Understood, thank you.
Yeah. Good question.
Thank you for the good presentation. Some of the bigger issues, Gina DeRezzi from Ground Heat. One of the bigger problems sometimes is that after a few years of installation, you have some facility managers that think they can be cheaper with gas if you have a gas backup and not have geothermal run during the winter. And then over time, the temperature of the ground gets warmer and warmer, and they say, well, the geothermal doesn't work for cooling. So this is an issue that we see. We presently have a 27-story building that this happened to after trying to salvage it.
I mean, great question, because again, it requires 365 days. You need summer, you need winter, you need intermediate, And if they stop in one of the seasons, then you're throwing off the ground temperature. So this system is intended to run year-round. The time where you could allow some natural gas or propane injection, if it's extremely cold out and you're concerned from the dedicated outdoor air systems not being to keep up with the frigid air temperatures, you could have an injection tee as part of the return header and be able to inject some energy, whether it's cold or hot, depends on whatever resource is. Just have this as a resiliency plan. And that injection tee can come in really handy because you never know when you're gonna need it. You need resiliency and backup with these systems. And that's part of the resiliency components, is a multi-fuel injection point just in case. But and I agree with you, some sites, the well field was too hot after many years. And then they had to install injection tees and cooling towers to get rid of the heat. So it's a system that requires responsibility. It's not a plug and play. You really have to make sure you have a trained facility manager who understands how to run the system per the operating manual that came from the commissioning agent and design engineer, because there is a responsibility. Renewable technologies are not plug and play, whether it's wind or solar or geothermal or batteries or biomass. None of these are just plain vanilla. They require training and attention.
One more question if we have it. Okay, a couple things. One, something that we haven't really announced a lot, and it's going to happen at 12:30 during lunch. If you have spent your time with our exhibitors, and we hope you do, there's a session that's in the Greenpoint room, which is down to the right. It's an interactive session where we're looking for feedback on priorities in geothermal in New York State. NY-GEO has been working with some of our members for about a year with various meetings, and we've got all these things we got to do to scale. Financing, permitting, marketing, all those kind of things, but we can't do them all, and NY-GEO is willing to help us do what they did with AirSource, and that is figure out where our priorities are. So if you have time and you'd like to join us, as I said, it's interactive. We're going to talk about where we really need to put our efforts and some of their efforts in terms of priorities. So that's just a little bit more information. As far as credits, up in that corner table up there, I've got a sheet with names on it if you've signed up already for credits. And it's small type, so please be patient. We'll get you through. All you got to do is find your name and sign it. If you haven't signed up for credits, you forgot, or the system didn't work when you registered, I've got a couple blank sheets of paper. Put your name on there. Please make it legible, and then we'll follow up with you. Probably need to go over to the information booth, our center, and pay your $100. Okay? So how about a round of applause for our presenter?
Thank you.
Thank you for being here. We've got a half-hour break, and then our next session, and then lunch. So
thank you all for coming. And we have another session at 1:30 over here about commissioning certifications.